share it. I start the streaming on YouTube, and you can use the recordings after the camp and during our camp. Okay, so I'm going to share my screen again. Okay. Yeah. So, oh, perfect, surprise. You can learn Russian language. Okay, welcome to Aerial Robotics Skills Camp. This is a camp. Will be provided by COEX and Workspace Russia. And let's get acquainted. My name is Svetlana Solomatnikova, and I'm chief expert of this camp. And also, I was a chief expert in the Workspace Kazan. I'm responsible for providing some international activities with drones and competitions, and so on. Okay, welcome to our winter aero robotics skills camp. Today, in this camp, we united 15 countries on our camp. It was really unexpected for us, but it's really great because many of you has interest in the autonomous drones, and it's really amazing. So welcome teams from Austria, Azerbaijan, Barbados, Brazil, Costa Rica, Ecuador, Egypt, Ghana, India, Jordan, Malaysia, Mexico, Morocco, South Africa, and Tunisia. Yeah, great. Welcome, guys. Welcome. Yeah, so this is really widely spreading drones, and we are really glad to see new members in our community. So, guys, it's really amazing. So, and first of all, I would like to say thanks to Workspace Russia to have this opportunity for us, and I think. If Anna Malinovska is here. Anya, are you here?
Yeah, I'm here.
Yeah, hi. Perfect. Welcome, Anya. Please say us many interesting words.
Hello, dear friends. I'm very glad to see you all, to see Svetlana and the team. And it's very pleasant to see already familiar faces and a lot of new faces. And my congratulations to Svetlana and the team that you really break the borders and widen area robotics family from time to time, from event to event. And I want to wish everyone to spend this time productively and to spend it cool, to enjoy it. So welcome and good luck on this event.
Yeah, thank you, Anya. Yeah, thank you. Anya make really amazing work. She united and she collaborate with you all, and we work together. And each event, it's a really interesting experience for both sides, for me and for Anya too. Okay, so next. Next, before I introduce with our organizing team, I would like to give a word to our CEO of our company, Copter Express, Oleg. Oleg is here, I hope.
Yes, I'm here. Yeah. Hello, Svetlana and everyone.
Hey, hi, Oleg. Yeah, nice to see you too. And welcome, Oleg.
Yeah, thank you. So I'm glad to see everyone and welcome for everyone to join our camp. And I would like to think that you will be very pleased with this camp and will learn a lot of things and get a new experience and get a new connections, new friends, um, partners, and so on. And of course, you can consider us as your partner. Uh, and we are glad to be with you not only today, not only on this camp, but in further in future to work together with you to provide you our Clover Drone kits and our experience, answer your questions, and do our best for your for helping in your path in aero robotics.
Thank you, Oleg. And also, I would like to say that Oleg today is celebrating his birthday. Oleg,
Oh my
we
God.
are
Yeah.
with your birthday and wish you many interesting projects and have a good team. Congratulations.
Yeah, thank you a lot.
Yeah. Uh, okay, so I will continue sharing my screen. Okay. So, and now this is some big event. And during this event, our organizing team will support you. And let me introduce with you our lead trainer, Timofey Kondratiev. Okay, Timofey, welcome.
Thank you, Svetlana. It's going to be a very interesting 4 days for us. So I'm really excited to be with you here.
Okay. And also, Timofey, such as a lead trainer, and also we have a big support of our team. And during this camp, our great trainer, our best trainer, Nikita Bogatov and Elena Silverstova will support you too. So Elena, welcome.
Yeah, thank you. Hello, everyone. My name is Yelena. I work with drones and organize various competitions in the field. I wish you great success and believe that you will launch your drone to an autonomous mission you work on.
Thank you, Lena. And Nikita. Welcome, Nikita.
Hey, nice to see you. Good afternoon to everyone. My name is Nikita. I'm a student of the State University of Aerospace Instrumentation. I live in St. Petersburg. And also I'm an engineer of the Laboratory of Unmanned Aerial Systems. Right now I'm sitting in this laboratory. We also have become the hub of the International World Skills Challenge this year. For us, that is a great achievement. And from the behalf of my university, I want to thank Copter Express and the World Skills for such a good experience and for such great work with you. I hope that everyone during our winter camp will become a lot of good knowledges. And Oleg, once again, happy birthday to you. Thank you.
Thank you.
Okay, and of course, we have a interesting man, Chief Communication and Interpreter, Ilya Khukhuni. Ilya, welcome.
Yeah, hi everyone. Glad to see you here. As a chief communicator, obviously my primary goal would be to make sure that you have absolutely no issues in communications. You understand everything what's going on. If you don't, please contact me directly. There are various ways to reach me. And secondly, as a part of COEX family, I want to mention that Copter Express is really interested in developing the wholesome drone education in many countries, and we're looking to partners So if you do have any ideas how to promote drone education in your country, we'd be really glad to hear them from you. And let's communicate. So once again, I'm there for you. Thanks, everyone. I do wish you to have mostly interesting several days learning really new stuff for you. And I do hope that that would help you to reach new heights. After all, drones do allow you to do that. Thanks, everyone, and good luck to organizing team and especially Svetlana, who is behind all this. So applause to Svetlana and even more applause to Oleg in his birthday.
Thank you, Ilya.
Thank you, Ilya. Okay, so guys, don't forget about our good luck for this training. Okay, so this is our organizing team. And now I think we can continue.
Svetlana, I think you forgot to introduce Yelena.
So
we have already.
Yeah.
Really? Okay.
Yeah.
Really, you have missed this.
Yeah. Thank you, my team, for check each step. It's really important. Okay, so guys, I think we can start. So first of all, I will talk you about drones and occupations, about our skill, about our system work with where we can start from the school education and go to the work. I will tell you about us such as a global partner. And after it, we will start our first lesson regarding to programming drones. I hope you are ready and we can start. So I think many of you know that drone is the most popular and most famous type of the aircraft, type of the vehicles. And now drones application area is very widely. So it starts from the filming or search and rescue and up to drone swarms. Also, drones application, drones applies in the science and research, surveying and mapping, and also provide aerial delivery. And the scale of the drone can be different, start from micro and go to heavy for such as a transport for the people, aerotaxi, for example. And now, so the main idea of each camps of the skill, because we have don't enough good specialists in this area. So this profession develop rapidly and takes new knowledge, new levels in different areas of the professional job, so such as a hardware developer, software developer, the engineer who provides some test working, and of course drone operator. So this is their flow chart and graphics about what type of the engineers need to in near time for maintenance of drones and for maintenance of autonomous drones. Of course, the big part of it's software engineers. Next, hardware engineers and other types of the professions. And in this case, we have a focus on the software engineers teacher and preparing. And that is why our camp will have a focus on autonomous drones and programming skill. So now I would like to tell you about some historical moments in our skill. So we have started in 2016. This was our first national competition, and we have started from 5 colleges. In next year, we took a part in the first cross-industry competition and the first university league. We extend our age from 16, we start from 14 years old for juniors competition. And the high level of the age was 49 years for the young specialist. 2018 year, this was the first year where we took a part in the international competition. BRICS challenges was provided by China and South Africa in this year. And next year, 2019, we were such as a hoster of the first international competition of World Skills Kazan 2019. We united 8 countries, and we have 2 categories, juniors and adult. Also, in this year, we extended our age level, and we include senior trainings, and we call it small juniors, starting from 12 years old. So, and 2020, this year has many challenges for all of us, and this year make us develop rapidly, and it allows us to extend and involve new countries, new participants from all around the world. And we provide our first international camp in the remote format in July. Next, we will provide our first national competition in Russia for participants from Russia. And also in November, we have provided the first international competition, BRICS Future Skills Challenge. It's a really amazing year, and this year makes us some opportunities for developing and involving new members. And they're really glad that we use new technologies for providing online education. And also, early we have our name of our skill was drone operating, and it includes different tasks. But now we have a focus on the autonomous drones mostly, and we provide renaming of our skill to aerial robotics. On this slide, you can see our main test project models for offline competition. It includes BVLOS piloting, drone node modeling and prototyping, VLOS piloting using cargo delivery, and autonomous flight coding. But for online test project, we remove other models and stay only autonomous flight coding and BVLOS piloting. On this camp, we will focus only on autonomous flight coding. So this system of education allows us to combine different educational organization such as the schools, colleges, universities, and we, COEX, such as industrial company, we provide industrial tasks for these educational centers, and it allows to update curriculums, provide research activity, and provide involving students and school students in this new area. And really interesting to know what about your educational system, how it's happened in your country. So how do you use new technologies, and it's difficult for you or it's easy for involving? You can write it in the Zoom chat or our Telegram chat. It will be interesting. And also you can provide some short presentation for us some later. So next, I will provide some summarize of our educational activities for different age levels. We start working with the students from 12 years old for school students. Also, we work with the duet students from colleges. Now in Russia, this is a time for University League, and it's really interesting for us to work with the universities and provide some research activities in this area. Also, we work with other companies and provide educational for young specialists and retraining for their people who has 50 plus years old. To cover this big and non-interrupted educational process, we use educational quadcopter kits COEX Clover. It allows us to learn and to give you opportunity to learn assembling skills such as design engineering, soldering, 3D prototyping, and using this skill, you can develop any type of drones because you get the basic skills, and this skill is universal. Of course, piloting skill, such as the VLOS piloting, visual line of sight piloting, and FPV racing, for example. And the most popular and most famous, most important skill, of course, it's programming. We use a Python language and a robotic operated system to provide autonomous flights. We use an open source platform, and it allows us to preparing good specialists, because they start from Clover platform using PIC-SOC flight controller and Raspberry Pi, such as an onboard computer companion. And this tech use on our industrial drones named Pelican, and it is means that you can start to learn Clover platform, and after it, and then you can start use industrial drones, and you will understood their feature and provide the programming in outdoor. What is the interesting features of our working? It's a working with students and student projects. So we support interesting project from our students. We provide events named Copter Hack, and during this event, students preparing their project, their idea. They start from their idea and go to their real prototype of it. And some words about our community. So now we have more than 2,000 members of it, and we have provided more than 100 events, I think more 200. So such as hackathons, competitions, contests, some trainings, and it's really interesting these digits. So the average age of our member community in 23 years. It's really young, and it's allow us to find interesting and creativity solution in this area. So this platform of education, by the way, we use this system for schools, colleges, universities, and industries, and we give them not only the task, but we prepare in the atmosphere for educational, for engineering, creativity. So our drone educational platform allows to provide full integration with industrial equipment, and it's motivated to provide research activity. I think it's really important. So yeah, some words about our age levels. Yes, school students, they start to involve in drone industry area. Our students from the colleges, they pass the exams according to world skill standards and specification. Students from the university provide some research tasks. They use drones and this experience for provide their diploma project, and also take a part in international conferences. For young specialists, we give them a real-world task, and they work with this task to find the better solution and more efficient solution for the task. And of course, for the people, for our senior skills, so this we give them opportunity to move from oldest profession and to get new knowledge and be useful in the new profession. Yes, on one more thing. So we extended our age limits, and starting from this year, we will include education for the kids from 7 and up to 9 years old. Some words about our workspace area. So, of course, each competition, big competition, can be equipped to flight zone. And also on our competition and in our laboratories, in the university laboratories or colleges, their laboratory equipment, the popular and widely used equipment, such as professional equipment of tools, table, and solder station, and etc. for it. They use educational quadcopter for it. And also you can use and read more about our equipment, about what we do. In our websites, we collect all educational materials in one place. You can use it at free. And also this tower of knowledge update permanently, and in each time you can find something interesting. So how coronavirus changed our life and your life, of course? Yeah, we transform our courses and our activities into online, and we provide different training using different tools for it. So one of the most popular, it's using gazebo simulation. For it, you need only have a laptop, and you can try to program in drones in real time on your machine. And it's really fun because you can build the world and check interesting solution for drone programming. So for it, you need on the laptop knowledge of the Python and some mystery knowledge from our trainers. And also we use a real equipment too in our competition. So sometimes we organize the remote venue with the which equipped the real drones. So you can connect via Zoom to our remote venue and run the code on the real drone. So this is example from our latest activities, latest events. So the BRICS Future Skills Challenge was were held in the State University of Aerospace Instrumentation. Nikita told you about it before. And also some different activities we provide in our other universities laboratories, such as Moscow Institute of Nuclear Power, named SMIFI, and Moscow Polytechnic University. It's our new laboratory, and we provided some camp there too. So, and the most interesting question for us, why we are doing it. So this camp has a focus on popularization, networking, and knowledge exchanging, and of course, it's mutual help, because I think it's really important to build the strong community of a good specialist with right values, and it will be such a big family. And now you're a part of this community, of this family, and it's really a useful thing, I think. Oh, so guys, I think I hope you don't sleep during my lecture. Now, the short agenda for you. We have 4 days starting from now, and our each classes will start at 3 o'clock by Moscow time, and we finish in 6 o'clock. Today will be the first. Timofey will tell you about the first steps into programming drones. And the next 2 days will be include the lessons and practice. So pay attention on this day, and also don't hesitate to ask any questions. You can ask in the Zoom or Telegram chat, and Timofey, Lena, and Nikita will help you in permanently, because our main goal to give you the practical skill, not only theory. And to get the best practical skill, we will give you the daily homework, and you should to perform it, because it will be provide assessment of your homework. So I have finished my presentation. If you have now questions, you can ask me it now. You can use your microphone, for example, or you can use the Zoom chat for it. Okay, if you will prepare a question, you can ask me in the end of our today's meeting. But for now, I would like to give a word to Timofey, Lena, and Nikita, so you can start your first lesson.
Okay, thank you, Svetlana, for giving us the word. Well, I have another presentation. It's not going to be so long, and after the presentation, we will continue the practical part. I will demonstrate you how to install the simulator and what requirements there are for the simulator. And I will also share with you the environment that you need to set up for working and for making your homework. So let me begin the presentation. During the presentation, you can ask questions in chat, and we will answer the questions. All right. Do you see my screen?
Yes.
Okay, great. So welcome everyone again. What is the Clover Drone if we go more into detail? So there is a short video that demonstrates different capabilities of the Clover Drone. It is capable of flying autonomously using the code you write, or you can make any type of applications with different sensors, any sensors that you can imagine that are available in that size and that form factor for small drones. You can have a drone swarm with Clover, or you can perform some flips, and sometimes there are unintended like there. And the Clover is used in many different competitions, like this one, for example. You just saw a flip, autonomous flip of the Clover drone. You can program your own flip, or you can program flip for a swarm. So many things are available here. The drone is equipped with a camera that can be used for computer vision, OpenCV, and this task requires the drone to follow the line. Another application that we developed was attaching a 3D scanner to a drone and creating a 3D model of a human. You can also equip a drone with a magnet to grab some cargo, and you can simulate some real-world tasks with that, like drone delivery. So this is a competition that the goal of that was to deliver a cargo. Basically, the drone can be used in industry as well. This is an example of warehousing inspection. And here you can see a real world application in theater. So this is a drone show in a theater. It was probably the first drone show used in this theater, made with Clover as well. So basically, this drone is very powerful, as you can see, and you can create many different projects with that. All the links are available. I will be available in the presentation later, and all the documentation is available online for everyone. This platform is open source. You can read the whole source code of the Clover and modify it the way you want. So what is the Clover made of? It has a real Clover has, of course, frame, some motors, speed controllers, the FCU, flight control unit, the battery, RC receiver, and the controller. But we are focusing more on programming a simulated drone. So this part is actually a Raspberry Pi onboard computer. You can program it, or you can program the simulated environment in virtual machine that we will be doing today. The drone is equipped with IR rangefinder and a camera that I've already talked about. So how does the drone use the camera? The main application of the camera is to navigate indoor. This is a window of the camera from the drone with the arco markers that are used for navigation indoor, and they can be created. You can create your own marker layout, the marker map, and set up the drone for working with these arco markers, so the drone can know its position in space in your room. Those are the links for main software of the drone. PX4 is actually a firmware for the flight controller. It's an open source project developed not by us, but we are using it, and we have our own branch, so our own version of PX4 made specifically for Clover. You can navigate with computer vision. This is the link for that. Moblink is a protocol that connects flight controller with the Raspberry Pi. And ROS is actually a framework on the Raspberry Pi that allows us to program complex robotics systems. Those are the links for simulator and where you can download the simulator or learn how to use that. A few words about navigation systems. The most familiar navigation system is GPS. Those are satellites flying around the Earth and giving us the coordinates that we are in. But GPS doesn't work indoor. This is why we need to use something else. Some of the most popular indoor navigation systems are, for example, motion capture, but they are usually very expensive if you have set like that, or you can create a cheaper version of motion capture with your own web camera, but it might be not as responsive as the industrial type of things that give you a lot of precision in flight. The other navigation system that we are using is vision-based navigation. So the drone with its camera can detect markers, measure position of the drone relative to that marker, and compare this position to where this marker should be. So if a drone sees at least one marker, it can already detect its position in space, including rotation. And this is the gazebo simulator that we are going to learn today. Those are some capabilities that are available for you. So by default, there is no arco marker field. The drone is navigating using optical flow system that allows you to use the image from your floor as a reference to detect drone's shift in position. This is less precise than arco marker navigation, but it's okay for simple programs. And you can program the drone right in the simulator and run it. You can write scripts or run just IPython, for example, to work in real time. This is the rangefinder. It measures the distance under the drone. This is a simulated laser ray that can measure your distance for you. Optical flow requires rangefinder for work, but arc markers do not require rangefinder. They work without it pretty well. And this is how you can navigate relative to the arc marker. This is the whole map of markers. And the drone recognizes each marker, and the numbers, each marker has a number associated with that. So this is 157 and so on. Every marker is unique, and there should never be two equal markers on the field. You can also play around with the LED strip. You can program each LED, or you can program some animations with that. Some effects are available by default, like white and rainbow and some other. And it's pretty easy for you to work with it, like blinking and having some color. And you can also simulate some maneuvers in the simulator. This is a flip, but be careful, the settings of the flip should be different. They're usually different with a real drone flip. Okay. So the next, the recommended specs for the simulator. It's better to have more than 8 GB of RAM on your computer, because virtual machine requires at least 4 gigs of RAM, but basically 5 or 6 if you use it longer. And the best RAM is like 12 or 16 gigabytes. It's better to have like Intel Core i7 or i5, or a similar AMD processor with 4 cores and or more. And it's better to have a dedicated graphics card with more than 1 gig of memory. Like 30 gigabytes of free HDD space. And how do you install the simulator? There is a link for downloading this simulator, and I will show you how to find it yourself. Let me open. So if you go to clover.cox.tech, you go to our knowledge base, use English language, and here go to programming and simulation, then a VM setup. And here are the links for downloading the virtual machine. We recommend you using VMware Player for running our virtual machine. For Windows or Linux, and for macOS, it's VMware Fusion. And this is the link where you can download all of our releases. The latest release is version 0.3, and you can download it from that link. And how do you install it? Let me find the presentation. Yes. Okay. First, you need to check if your virtualization is enabled. So if you go to the Task Manager and use the Performance tab, look here in Virtualization and make sure it's enabled. It can be disabled by default, and if it is disabled, you need to enable it in BIOS or UEFI. So if it is disabled, you need to get to the BIOS and find, for your specific BIOS, find these settings like Intel Virtualization Technology, put it to enabled, and then it is enabled and you can run virtual machines. It can be in any other place if your BIOS looks differently. There is a video with a little tutorial on how to enable virtualization. If you can't do it with this video, just look on the web how to enable it on your particular BIOS. Then download the Clover image. The link is in this presentation, and download VMware Workstation Player. All the links are available. Then, after you install VMware Workstation Player, here is the interface of the program. You need to open a virtual machine. So download the virtual machine image and open a virtual machine. Proceed to the location of your virtual machine. Here it's called Clover Devel OVA. It can be named differently, but this file usually has a size of 3 gigabytes or more, 3 or 4 gigabytes. Okay, open it and then choose the path and then press import. And an error may be occurred. If there is an error, just click retry and it will be gone. And wait until the installation process is finished. But don't start the virtual machine yet. You need to configure its parameters. So click Edit Virtual Machine Settings. And this is the settings menu. And you need to set up the memory, processor, and so on. So let's begin with memory. Here is the 8 gigabytes of memory. So the computer has probably 16 gigabytes, so you can use 8 gigabytes for the virtual machine. If you have 8 gigs, I recommend you using 5 gigabytes of memory for your virtual machine. If you have less than 8, I recommend you upgrading your computer, or you will run out of memory very shortly. The next settings is processors. So click processors and select the number of your cores. If you have 8 cores, use 4 for your virtual machine. If you have 4, use 2. If you have 2, use 1. Okay, wait a second. Yeah, you can also set up network if necessary, but by default it works with default settings. So don't, you can just keep it the default. USB controller is also optional, so you can just skip these parameters, but then there's a display parameters, which is very important. Click here, Accelerate 3D Graphics, and select the memory, how many graphics memory is available for your virtual machine. The recommended amount is at least 768 megabytes or 1 gigabyte. Then go to the Options tab and click VMware Tools and click Synchronize Guest Time with Host. This is an important settings because if you don't click that, the time on your virtual machine will be different from your host machine. And if there is a different time, when you try to access internet, it won't be available. So you need to synchronize time then the internet on virtual machine will be available. Okay, now you can open the virtual machine by saving the settings and selecting your virtual machine on the left menu and hit play. Then it will run. Okay, so this is the installation process of virtual machine. On macOS, if you have macOS, there is a different process and a different software. So if somebody of you have a Mac, you can write me after this after today's meeting, and I will tell you what to do then. Okay, now let's go to the practical part. This is VMware Fusion and the simulator is already open. I can show you how to open it from scratch. Let me shut down the simulator. All right, so I open the VMware Fusion. And on the left menu, my virtual machine is here. I can play the virtual machine and the window is opened. Okay, this is the operating system, Ubuntu. All right, this is what you get when you first run the virtual machine. If you have just installed the virtual machine, you can click Gazebo PX4 and the simulator will be open, but there will be no any Argo markers that we want to have. So I'm going to show you now how to load the world for the simulator that we are going to use on our course. It's gonna be here. So we will send you the link. We will send you the archive of this folder. You need to extract this folder and copy. So I just hit copy and go to the virtual machine and Control V. So the folder is here now. And here you can find a folder called models and some files. Some files with the launch extension and with world extension. Launch files are configuration files for ROS, and the world file is the file that contains world for the Gazebo simulator. Okay, let's begin installation, the world. I will open the home directory here, and first I will type in the path line, I will type .gazebo. It's important to type manually because folders or files are hidden and you will not see it here. I type .gazebo and I will move the models folder to this .gazebo directory. And here we can find a folder for each model that is going to be used in our simulator. Okay, go back home. And now I will need to put some launch files to its place. Let's begin with Catkin WS, SRC, Clover simulation, launch, and you'll find the simulator.launch here. I will drag my version of simulator.launch and replace it. All right, let's go back home. Catkin WS, SRC, Clover, then Clover again, and launch. And there is Clover Launch and Arco Launch, two files that are already here, but I need to replace them with my version. Replace all. And one file left, go back home and Catkin, WS, SRC, Clover simulation, resources, worlds. And you will not have the Clover 2 world. You will only have this Clover.world, but I will put this and replace. If you don't have it, you just put it here. All right. And now the simulator is ready to start. I double click the Gazebo PX4 and wait for it to load. Okay, this is the world that we are going to use. You can see the drone, Clover, and the Aruka markers, as well as some objects with different colors and positioned in different places. The drone is standing here, and you can see that LED of the drone is changing, and it is a rainbow. It means that the drone is working, and you can even take off using a command called commander takeoff, and you need to type it in this console. Oh, sorry. Oh, some problems. Maybe I need to restart the simulator. Sometimes the problems may occur. And when it happens, you need to just Control-C in this terminal and open the simulator again. Control-C will close all this simulation software, and when we open it again, it will reopen it. It is Control-C, yes. I have a question. It is Control-C, not Control-Z. Okay, now Commander Takeoff seems to be working fine because, let's see, oh, it didn't happen. You know what? It's better for me to show you first the with the other simulators. So I will open another virtual machine that I have installed that is proven to work, just for demonstration and in order for us to keep working on schedule. Okay, I have loaded another world from another virtual machine. It is a little bit different, but that's not a big problem here. Let's Commander take off. And now the drone is taking off, and it's flying. It's going to keep flying in the one spot, and without moving too much from side to side. And the height is going to be around 2.5 meters, default height for this comet. Okay, we have tested that our drone is working, and now we can start programming, because for now it is just flying and that's nothing else. And we want to begin programming our drone. So let me Commander land the drone, Commander land. Okay, for now I will close the simulator and I'll show you what to do to write the first program. All right, let's go to the website. So this is the clover.org/tech, the programming part, the article. You can just click programming here, and you will see in the first article, there's a code example available. So this code you can just copy and use it as a script for your drone. Okay, I open my virtual machine and I will create a folder for storing our codes. Let's create a folder here in the home directory. Create new folder called codes. All right, this folder is empty for now. Now let's open Visual Studio Code. and click Open Folder. Navigate to the Home and Codes and click Open. Click OK. Okay, the folder is open and we can create our new program. Create new program. 1.py. It is important to write 1.py. The extension should be py for the program. And here I can paste the code. After we test this code, I will explain you in more detail how to read this code and how to write it on your own. So first, the drone takes off and hovers 1 meter above the ground, waits for 3 seconds, flies forward, then waits for 3 seconds, then lands. Pretty simple. So I will save it, Control S. And I will change something in this code. Let it be not 1 meter, but 1.5 meters instead. And let's hold 4 seconds here. And fly forward for 2 meters instead of 1. And wait for 6 seconds and then land. Okay, it will be more easy to understand if the program is working fine. Now let's start the simulator, and there are 2 ways of running this code. The first way is you can open another terminal and go to the codes directory and write python.1.py, python then 1.py. I will show you that way. Another way is to just click this run button here. But I will show you the first way because it is more popular when you are using a real drone. Let me check this light condition. That should be better. All right. I will minimize all the windows and open another terminal. I cannot use this existing terminal because it is running another program. So I can't use this one. Instead, I will use a new terminal. Go to the directory codes, enter. And here I will write Python and 1.py. Enter. Let's see what the drone does. And you can see that the drone is flying kind of slow, so it's not very fast. And that's because the simulation is running not in a full speed. Particularly now, it is running at 18% of the speed because of heavy load. And you need to have a quite powerful computer to have a real-time factor of 1 or 99, 0 to 99. So my simulation runs as 1/5 or 1/3 of the real-time speed. So the drone goes forward for 2 meters and lands. Okay, this is how you write a simple program, but we will go into more detail a little bit later. Let me go back to the presentation and I will explain you something more about how to program the drone. For now, I will close the gazebo. Okay. So as we have Linux, I don't know how many of you are using or are familiar with Linux, but for you who are new, this is going to be useful to know. It is important to know the basic command line commands for Linux. Why do we even need to know them? Because when we are working with a real drone, we only have a terminal available. We don't have this sophisticated user interface like folders and links and so on. We only have this terminal, and we connect to our real drone from our computer through SSH, which is a way to connect to a remote computer. And those are some important comments that need to be for you. You need to know them. So CD is the first important comment. It's called that way because of change directory. So it stands for change directory. For example, if I'm in the codes directory, I can type CD and click enter, press enter, and I will go back to the home directory. But where exactly is the home directory? If we open home from our desktop, we see that this is actually /home/Clover. And Clover is the username on this machine. And if we are in our home, so this is a default location. If I open a new terminal, it's always in home. And you can see this blue tilde symbol, and it means that we are in home. How do I make sure that I'm there? I can type ls, and it shows me the list of files and directories inside this directory. And we can see that there is catkin ws and codes, which is the same as here, catkin ws then codes, and so on. Every other folder shows us that we are in home Clover. And I have already showed you that there is ls command. It gives us the list of files and directories. But there are hidden files and directories. How do we display them? We can type ls -a, and there's much more. The output is has much more items. So there's cache, ccache, config, then some ROS, some SDF format, and many other hidden files and directories. npm, npm global, Mozilla, IPython, and so on. Bash or C and some other system files, including the .gazebo folder that you used to put your models in. Okay. The next command would be rm. Stands for remove. You can remove folders or files by typing rm spacebar and the name of your file or a folder. For example, I can delete the program that we just made. If I go to the codes, I can type rm 1.py, enter, ls, and there's no that file. If I go back, I can remove the codes folder. I will type rm, but it will not remove the codes because it's a directory. In order to remove it, we need to type rm -r codes. And now there's no codes directory. It will remove the codes and all the files inside the codes. All right. You can create a directory using mkdir codes. And now there is codes directory. Okay. I didn't tell you how to go back to one folder. If I go to cd Katkin ws src clover launch, you remember that directory? We have Aruco launch and Clover launch there. If I go there, I can go up to one directory higher using cd ... And now I'm in Clover. If I go cd ... /... I will go to the src. So I jumped up two levels higher. If I just press cd and enter, I will go to the home like again. All right, you can move files. The mv command moves your file, but it doesn't only move file, it also can be used for renaming files. So there is no rename command in Linux, there's only move. For example, if I have a program, let me go to codes and create a program. I will create the program here, 1.py. Save it. All right. I have a program 1.py. I can move this program by typing mv, or I can rename this program by also typing mv and then 1.py, 2.py. It will find the 1.py file and rename it to 2.py. ls. Now it's here. But you can also, if I want to move 2.py to the home directory, I will type mv 2.py. And here I will need to specify the path to the directory where I want to store this file again. The easy way for finding home directory is typing tilde. It is here. Yes, this symbol. In this, it stands for home. And I can type tilde/2.py. It will move the file from current folder /.py to home/.py. Let's go back to the home directory and find our 2.py. This is great. And if I want to put it back, I will type mv 2.py and I can type codes/2.py. It will find the codes directory and will create a new name, 2.py. ls, there's no more 2, and it is in codes. All right, learned that, remembered that, and great. Let's go now. Let's go next. Nano is
Timothy, one moment, please. So, yeah. Could you increase the font, the size of font into terminal?
Yeah, let me do that.
Okay, it's good for Zoom, but in YouTube has some.
Thank you.
Not quality. No high quality.
So for those who, if you didn't see that, all my comments are here, and this is the history of my comments. So you can see everything I typed before. I will scroll it up. All right. The next is Nano. Nano is a text editor built into the terminal. So you can either edit files or create files with Nano. I will edit files first. Nano 2.py. And actually, if I press tab, it will autocomplete the name if it can complete. So if there is only one file starting with 2, I'll hit tab and it will complete it with .py. Enter. And this is the interface of Nano. You see that the content of the program is in this window. I can only use my keys to move cursor. I cannot use my mouse. I can only use my keys. And there's also some other commands. This symbol stands for control, and if I hit Control X, it means exit. Control G is help. Control O is write out, means save, and Control R is read file, and so on. Some other commands are also available, hotkeys. And for example, I can edit my program. Let me change it to hover on 1.5 meter and wait for 4 seconds, and here fly forward to 2 meters and 6 seconds. All right. How do I exit? How do I save and exit? Yeah, I will press Control X and it asks me to save the buffer. Do I save it? Yes, of course. I hit Y and it asks, what name of the file do you want to save? I want to keep the old name. It is 2.py. I just hit enter. And if I want to use Nano again, I can, or any previous command, I can use arrow up, and enter. This is our program again, and you can see it saved the changes. So I will make another change just for demonstrating you how to quickly save the file. It is Control X, Y, enter. That's it. Okay, Python is the command for running Python scripts. If I try to run this script right now, it will not do that because I have no open the gazebo. But I will try to do that. Python 2.py, enter. And you see that there's an error. The navigate service is not available because the gazebo is not working, the ROS is not working. And sudo is a command that tells you to execute the following command with a super user rights. It's like an administrator or root user privilege. For example, if you cannot edit a file, you need to open it with sudo. The example of files that cannot be edited so easy are some system configuration files, like the ones that control the Wi-Fi settings of the machine and some other. It is not used so often, so just keep in mind that you need to run programs with sudo sometimes, like sudo python and 2, but don't do that. It may cause some errors as well, so don't run it with sudo. Python is just without sudo. Okay, it was the list of basic commands. Next, the coordinate systems or frames. This topic is it's not so easy to understand for beginners, but I will explain it to you so you at least can try to understand it and grasp the information that I'll give you. So what are frames actually. I will open the program here and I will show you how to code with frames in mind. So let's look at the first navigate service. What is that? Navigate is actually the service that moves your drone to another position with certain speed and in certain frame. Frame is the coordinate system. In this case, we are moving the drone 1 meter along the axis, 0 and 0 and along X and Y, using frame ID body. What is frame ID body? So basically it is frame ID. This is a coordinate system that comes from the drone's position, but it doesn't count the drone how it's tilted in the space. For example, if the drone is standing on the ground on some, it's not horizontal, the frame ID body will put you up vertically up anyway without taking into account the drone's tilt. I will open an article on frame ID for having more reference information. Where is that? Yes, coordinate systems. So body is bound to the drone, but the axis points up regardless of the drone's pitch and roll. So yeah, pitch and roll are not used in calculations. Yaw is used, yes, and it is shown by the red, blue, and green lines, yes, in the illustration. So this is actually the frame ID body. And if you are trying to navigate with frame ID equals body, the coordinates that you provide are calculated starting from this point, like what we just saw here. It's x0, y0, z1. So the drone will ignore the x-axis and y-axis, but z-axis will be taken into account, and the drone will increase its height to 1 meter by 1 meter. If you just type like here, if you type x1, y0, and z0, it will go straight forward without moving up or left and right. Okay, this is the body frame ID. But we also have ArcoMap frame ID and map frame ID and some other. I will tell you, for now, I will tell you about ArcoMap, then about other frame ID. Basically, map frame ID is the default root frame ID, and all the transformations come down to the map. But for our ease of understanding, we mostly use ArcoMap and navigate around this frame ID. So let's look at the ArcoMap. This is the center of coordinates, the point with coordinates 0, 0, 0, 0x, 0y, and 0z. And when we are working in ArcoMap, we need to provide absolute position relative to this point every time we change our position, every time we use navigate. How do we program that? Let's go to the program, and instead of flying to 1, 0, 0 in body, we will fly to certain coordinates in ArcoMap. Let's do that. So it is navigate. Let's go to the coordinates 4 by x, 2 by y, and 1.5 by z. Frame ID, change it to ArcoMap. And for that flight, I will need to provide higher speed. So speed equals 1. The default speed is 0.5 meters per second, and this is 1 meter per second. I will also increase the time to 10. It keeps telling me that it is deleted, but it's not. Okay, let's demonstrate this flight. And where is the coordinates that we just provided? It was 4 by x, 2 by y, and 1.5 by z-axis. Let's count it from this position, which is the center of coordinate system. 0x, 0y, and 0z. X-axis is pointing to this direction. So let's count 4. 0, 1, 2, 3, 4. And this is the line that the drone will be hovering over. And now let's count 2 on y-axis. 0, 1, 2. So the drone will be above this marker and the height of 1.5 meter. Let me show you now the other way to run the code. It is from this button, the run button. The terminal is opened there in Visual Studio Code. And let's see, the propellers are now spinning and the drone will take off shortly. Remember the position we are going to, this. The drone now is flying to the position that we provided with navigate. And now it is there. You can even click the drone and see its position. It's 3.9x, 1.8y, and 1.5z. Well, at least used to be when I clicked. So this is the frame ID Aruka map. And now, if we want to not only go here, but also fly then forward, like fly 3 meters forward on the same height, what do we do then? Let me write this type of program. I will remove these comments because I don't need them anymore. I will also increase the speed in taking off, equals 1. And I'll tell you a little bit about auto arm true. What is auto arm true? So arming of the drone meaning that the propellers are starting to move. And this comment, this argument of navigate tells us that the drone will spin the propellers if they were not spinning. And we only need to use auto arm true when you take off, and don't use it in any other navigate because it is dangerous. I will tell you later why it is dangerous. So only one auto arm true when you take off, or if you landed and then you need to take off again, you also need to set auto arm equals true. And here in this navigate, I don't use auto arm true. So, okay, these 3 seconds, those are 3 seconds that we need to give the drone to have time to take off. So once it's starting to take off, the 3 seconds count starting, and after 3 seconds, it will start executing the next command. For the next command, I've set here 10 seconds, which is more than enough for flying, like a little bit more than 4 meters with a speed of 1 meter per second. So I can have like 6 seconds here. And let me copy these 2 lines and paste it below. I wanted to fly 3 meters to this direction, to X. And for doing that, I will just need to increase X by 3 meters. It will be 7. Y and Z and Z remain the same. The time for that flight, let me have like 5 seconds. So it hovers a few seconds after it reaches the position. Then I want to go to the original position, the position where the drone took off, which is X0 and Y0. And for that flight, I will give it 10 more seconds. And frame ID is org map everywhere. So the drone goes back to this position and lands. But what happens if I run this program from this point? Will I notice the flight from the 0 point to here? But I don't think so. Let's try. The drone is spinning its propellers. And it is taking off. So it stayed in the same position for some time, and now it is moving forward. So this direction is actually forward. If you zoom in to the drone and look closer, I will show you that this is actually a forward later. Now it goes to the original position. Okay, let me zoom in and show you how the drone looks. So this is the camera, and it is pointing down. And the front of the drone is pointing to the x-axis. The battery is fixed that way, and it may seems like the front of the drone is somewhere on this side, but it's actually here. Okay, let's look at the code again, and let me now run it from this position, so you can see how it goes from start to the 4x to y, and then to 7x to y. So it went from here to here, from here to there, and now it's going to 0, 0. So this is how you can write your first program. And now let me show you how to use our knowledge base. Where do you find information about other commands and other services? So Clover module for Python is the module that contains important services and other functions that are necessary for programming the drone. And you can find the article called, let me see, it is called Simple of Board. It is in programming and Simple of Board. So Simple of Board I have a question called, please highlight about how to move the drone on the basis of ArucoMap ID. What exactly do you mean by that? So how do you move the drone in frame ID ArucoMap? Okay, I will highlight it a little bit in more detail. So, okay, how do you move the drone based on the ArucoMarkers map? So whenever you need a new point, so first make sure you understand what coordinates in each point R. For example, if you have a spacing between each marker 1 meter, so between the center of this and this and this, then this marker has the coordinates 1, 0, 1, 0, 0, and all the other markers can be easily calculated. All the coordinates of other markers can be easily calculated by going from 0. Like if I want to know the coordinates of this marker, if I know that there is 1 meter exactly between two markers, I calculate first x, 0, 1, 2, 3, 4, then y, 0, 1, 2. This is 4 and 2. And for flying to this marker, I need to use navigate like that. Navigate, x equals 4, y equals 2, z equals 1.5, because I want to fly above the marker so the drone can see the marker. Then speed is optional, and frame ID is necessary. So frame ID equals arcmap. And you are flying to these coordinates. Then you fly to other coordinates. If I want to go like 3 meters forward, I type x equals 7, because 4 plus 3 is 7. And I leave 2 and 1.5 the same, and the drone goes there. And the time for the command is also necessary here. You need to provide enough seconds for this flight. If I want to go to 0, 0, I can go to navigate x equals 0, y equals 0, z equals 1.5. And also, if I don't want to type 0 and 0, I can just leave it that way, because the default for each x, y, and z is 0, so it will still go to 0. I hope now you can understand that. And let me go back to the article, the symbol of board. Okay, symbol of board. In this article, you'll find this description of each service available. Each service for the flight, of course, because there are other services that are not used in programming. They are more for internal use, but you don't need them. And also there's the code example that you need to copy to being able to use the services. And let's look at my program. So here we can see that import ROSPy is the first import. Yes, you need to import ROSPy for programming Clover. Then from Clover import SRV, and from std SRV as data SRV import trigger. You also need that, and it is also easy to find on this code example. Basically, you just copy that and use. Oh, the question is, how do we specify the value of z? Well, this is not diagonal. It is just a height above the ground, and that's it, nothing more. The drone will go diagonally from each point to the other point, and so if you have 2 points, if I go from the point A to point B, the drone will follow the shortest path, the straight line. If the first the height on the first point is 1 meter and on the second is 2 meters, it will go. It's still the shortest path. Yeah, great. So in order to use services like navigate, you need to specify them here. Navigate equals ROSPy.service proxy, and here is all the necessary information typed in arguments of that. So I can actually delete unused lines from here, like navigate global, which I will never going to use in this course, because navigate global works with GPS. And set rates and set attitude, set velocity, I will probably not use them. I can delete them. Set position may be used, and land if really is used. Get telemetry is also used quite often. So let's go now to the API description part of the article. And the first service presented here is get telemetry, which is the service that gives you the parameters of the drone. Frame ID, it is X, Y, and Z coordinates. The armed status, mode, and the connection status, the connection between flight controller and the Raspberry Pi. Latitude, longitude, and altitude if available. Velocity on each axis, on X, Y, and Z. Pitch, roll, yaw. Pitch rate, roll rate, yaw rate, which is angular speed, angular velocity actually. And the voltage of the battery and cell, the voltage on the average voltage of the cell. So this is, we are going to use this tomorrow. And this is how you can use them in Python. The next service to be described is navigate, fly to the designated point in a straight line. X, Y, and Z, yaw, yaw rate. We didn't use yaw and yaw rate, but they are actually, they rotate the drone. The speed and auto arm, frame ID, and that's it. And those are some examples how to use that. Navigate global, yeah, you specify longitude and latitude. Set position is more low level than navigate, because it doesn't, you cannot set speed. In set position, the drone will actually fly in the fastest speed available, but it is very useful for short distance flights. Like if you calculate the position multiple times per second, then set position is what you need to use, not navigate. So we will also probably use it in the following days. If not, then just there are some code examples where code snippets in this article, you will find the use of set position while making a flip or making a flight in a circular path. Set velocity, I'm not going to use that, but it allows you to set the directed velocity to each direction as you wish. Attitude is setting the pitch, yaw, and roll of the drone, as well as thrust. So the drone will, if you want for the drone to go to this position and stay in this position, which is will lead you to fall, but you're still allowed to do that with set attitude. But it's not very useful for basic flights. Set rates controls the rate of each, the rate of rotation of each on each axis, like angular speed and thrust. It will be used in flip, for example, and so on. Land is just makes you land, makes the drone land. So this is where you can find all the information about how to use services in Clover. I see some other questions. Can I use Ubuntu over Xubuntu? If you are already using Ubuntu, you can install Clover right in your Ubuntu without using virtual machine. And this is actually recommended. because the performance is going to be much better. How to do that? You go to the simulation article and the native setup. Here in native setup, there's instructions. There are some instructions on how to install it, but you might have some troubles while installing it because depending on your system, you may have missing packages or so on. But still, you can run it on your own Ubuntu and without any big troubles. Yeah, so simple of board is how you write your programs, and the article is called simple of board, and the link to the article is here. The final function for today is going to be the navigate wait, which is this is a function that allows the drone to fly to a coordinate, and it will actually wait for the flight to finish, and then it will perform the next navigate wait. Why do we need to do that? Like here, for example, we are always providing Robotics sleep and some seconds. But we need to calculate it manually or in our mind, and it is not very useful in type of coding. You can actually avoid doing that, as well as avoid typing every time the frame ID and speed and something else, unnecessary information, and focus on only coordinates that you are going to visit with the drone. And this is where navigate wait function is used. How do you find this navigate wait function? It is presented in code snippets. Let me show you code snippets article. Yes, this is here. And fly towards a point and wait for the copter's arrival. This is navigate wait. You can copy this function. If you're familiar with Python and with programming, it's not going to be that difficult for you. But if you're not familiar with programming at all, I know some people who start learning drones and do not know Python. What we still can, I can explain you how it works, and I will demonstrate you how to program that. So I've just copied the function, but notice that here on the top have import math. This is a module that is required for this function, the module that we need. Math. Let's go to our program, and I will insert the function right above the first navigate and after all the services that are created here. Def navigate wait. So def means define, so you create a function with def. In parentheses, you've got all the you've got arguments of this function. The default values are also given here, but some of them need to be changed. For example, frame ID needs to be specified in order for us to work with ArgoMap. So the first thing I change in navigate wait, I specify the frame ID to ArgoMap. The next thing is yaw equals float none. I recommend you just using yaw equals 0. It will not cause any other problems. But yaw float none sometimes works incorrectly and causes some hidden errors. So just use yaw equals 0, or if you want to rotate the drone, you need to specify the number. For example, if I want to rotate the drone 180 degrees, I will use yaw 3.14, which is pi. So every rotation is given in radians, so this is why I typed pi here. But for 0 rotation is just equals 0. Okay, those are default values. And another change is z. The default z, I want it to be 1.5, so that I don't need to, so I won't need to find, to always specify the height of the flight while calling the navigate weight function. This is the body of the function. So everything that is on at least this indentation is inside the function, and then the other code can be written. All right, let me replace every navigate and Robotics sleep with newly created navigate weight function, but I forgot to import math. Let me import math first. Yes, now I have imported math. Let's go down and here replace everything with navigate weight. Okay, how do you take off with navigate weight? You just need to specify a different frame ID and change auto arm from false to true. So I'm calling navigate weight, and here frame ID equals body, auto arm equals true, and now the drone will take off to the height of 1.5 meters. Why that? Because the default coordinates are 0, 0, 1.5. The next navigate weight will be the position that we are going to. It was 4 and 2. So that way I can replace the default 0 with 4 and the default 0 with 2. The z remains the same, as well as all the other arguments. The next navigate weight is 7, 2. And then I will go to the coordinates 0, 0, 1.5 because this is where we take off. But I will actually don't need to type anything here because it is already 0, 0, 1.5. So navigate weight with empty parentheses is what I need here. Then land. So this is it. This is how you can write your program with navigate weight, which is much easier and faster after you have pasted the function navigate weight and changed a few things like yaw, frame ID, and what else? The default z value. I would also change the default speed to 1 meter per second, actually. So you need to change yaw, speed, frame ID, and z. So this list of arguments. That's it. And don't forget to import math. All right, let me save it. After demonstration, I will explain you the math behind this function. Okay. I'll run this program. Okay, then what does tolerance represent? I wanted to explain that when going deeper into how it works. So tolerance basically is the distance from the desired point at which we count the flight as over. For example, if it is 0.2, it means that if the drone is close, if it is closer than 0.2 meters to the position it was heading, then it will start the next navigate weight. So the drone is going to the 4, 2, and 1.5 now. Once it hits this point, it will go to the 7 to 1.5. Yeah, it is now going to the next point. All right, go back. Yes, the drone has landed. As you can see, you can now you can use any type of route. You can fly around any corner of the Arroco map by just typing its coordinates and inside the navigate weight function. And now how it works in more detail. We have another unknown argument called tolerance, which is the distance at which the flight counts and counts as over. How it is used? How is it used? First, what the function does is running this code. Whenever you call the function, it starts with this line, navigate, and here in navigate, you get x, the default navigate x, and you replace that x with the navigate weight functions x, which is 0 in this case, or it could be 4 or 7 if we specify the other. So each argument in navigate is equal to the same argument of the navigate weight. So yaw equals yaw, speed equals speed, frame ID equals frame ID. That means frame ID equals frame ID, which is equal to Arroco map, or to body, like in this case. Then auto arm equals auto arm, which is false by default. And tolerance is not used in navigate. Tolerance is used in this loop. Let's begin the loop. While not Robotics shut down, that actually means that for those of you who are familiar with Python, you will understand what does it stand for. It stands for while true. But instead of true, we are using not Robotics shut down, because if you are going to use while true, it may cause troubles with closing the program. I experienced this trouble multiple times because sometimes I use while true, and I just hit Control-C and the program just doesn't want to stop. And for avoiding this problem, you need to use while not rospy shutdown, and rospy.isShutdown returns you false while the program is working, and not inverses false and makes it true. So while not rospy shutdown returns you true unless the program is closed by the user or by some other system. So basically it's infinite loop. It's an infinite loop. Then you are creating a new variable telem that will store the get telemetry response. Get telemetry is a service that returns you the parameters of the drone current flight. For example, its speed and its coordinates and battery level and so. For example, here we got telem equals get telemetry frame ID navigate target. This is a frame ID that I didn't tell you about yet. Maybe this is just the time for you to know about that frame ID. So coordinate system frame. Navigate target is the frame ID that is bound to the navigation target. What is the navigation target? Let's imagine that this is the drone and this is the point 4 to 1.5 that I just use as the default, as the first flight point. So this is 0.4, 2, and 1.5, and this is the drone. If you are using calling get telemetry with the frame ID equals navigate target, the coordinate system will rise from that point, and it will return you X, Y, and Z of the drone in this coordinate system, in this frame. And the distance from the drone to this point will be easily calculated using that X, Y, and Z that is given in this telemetry. I see the question, what will happen if it will be false while will it continue working? Do you mean what happens if the drone falls? Sometimes it continues to work, but the other times it will not, because PX4 simulation is when you hit a drone, the sensor data will be messed up and the drone will just lose its position lock and it might not work. So you need to restart Gazebo. Okay, let's go back to the get telemetry. So telem will store the response of get telemetry navigate target. It's better for me to demonstrate to you how it works exactly. So let me just do the following thing. I will go to this point 4 to 1.5, but we'll set the speed to 0.5 and the coordinates not 4 and 2, but 9 and 9. Okay, and now let's do a little change in this navigate wait function. I will add a print here, print telem, and it will always print us the current telem, which is get telemetry with frame ID equals navigate target. And you will easily understand how it works after I run this program. At least you will understand what get telemetry is. And while it is opening, the next thing is happening. That's happening is if the squared root of telem x squared plus telem y squared plus telem z squared, if that squared root is less than tolerance, it will break the cycle, the loop. It is basically using the Pythagorean theorem for in 3D space that will return you the distance of from point A to point B in 3D space. All right, let me read the questions. What is the reason behind using PX4? Can we use our dopiled mega? Well, we've got a whole webinar on that topic. We've got a whole webinar on PX4. I will give you the link in the chat. Where is that? Well, I think it is in Russian, but maybe there is also in English, so I will ask later. So PX4 is an open source platform, and it is the architecture of PX4 is more suitable for the needs that we use. For the correct functionality in Gazebo, you will suggest install ROS or Gazebo. I suggest you following the tutorial if you want to install it on your own machine. All right, let me just run the code before we over this today's meeting. All right. What exactly the condition are you talking about? All right, I will tell you just a second. Okay, now the telem is printed every time it updates, and you can see that X, Y, and Z now they are all almost 0 because it is taking off and it is measuring distance to the first line, to the first point. And now you can see the other. Wait a second. It will update when I scroll down to the. Yeah, now it is updating, and the X is -6, Y is -6, Z is 0. Basically, the drone is measuring its distance from its current point to the final point. When you are calling the get telemetry with frame ID equals navigate target. Whenever the squared root of the sum of squares of X and Y and Z will be less than 0.2, the drone thinks that it is, and the flight to that point is over. So it will be over shortly. We will wait until it is over. Then the coordinates X, Y, and Z will be updated according to the next navigate target because the next navigate will be called. And you will see the difference in coordinates very shortly. Now it's close to 0. It says almost 0 now. And it will hit. All right, now you see that X now is almost 2 meters, and Y is 6 and something meters. So the drone is now moving to the next position, which is it is there. And whenever the square root of sums of the squares of x and y and z will be less than 0.2, the drone will go to the final point. And now while it is flying, I will explain you how the if works. All right, if math sqrt. It is a square root of the sum of telem dot x squared. So star 2 is squared plus telem dot y squared plus telem dot z squared. So you will just calculate the hypotenuse of this parallelepiped. If you're familiar with math, you will know how it works. So now the drone flight is over. And then what happens when it is really less than tolerance? It just breaks the loop and goes to the next navigate weight, or if there's no next navigate weight, it just lands. Okay, this is it. Enough theory for today. And you know your home task, and we will tell you the task very shortly. And now I will ask Svetlana to continue after me. Svetlana, are you here?
Yeah, I'm here, of course. So, did you finish?
Yes, I finished.
Okay, so guys, what about you? Timothy, you need the screen sharing for now or no? No? Okay. Okay, guys, so where are you? And how are you? How was your first day? Oh, yeah, I see. Gabriel, yeah. Gabriel is okay. David? Oh, go. Okay, Timo, how are you? Oh, perfect. Jorge? Yeah, perfect. Oh, guys, I think you are ready. Oh, Scarix. What about you? Sebastian? Okay, okay.
I'm fine. Yeah.
Great. Raul? Oh, guys, I thought that you...
I'm fine. Thanks for asking.
Perfect. So I thought that you have tried, but it was my mistake. Okay, I think you are ready to get new information. Don't worry, it will be easy. So before we finish, so some organizational info. First of all, I would like to give you some. Okay, so I would like to give you some information about your homework. Timothy, did you talk about the homework or no?
No, I haven't described the homework.
Okay, it will be my fantasy for your homework. Okay, guys. Okay, so let me share my screen. Just a moment. Okay. Some technical problem. Okay, so I can make your life some easier. Okay, this is your homework for today. You should to install the gazebo simulation. You can run any code of examples, and also try to perform a mission like this one. So fly trajectory by square. This simple task will help you to keep your new knowledge and upgrade your skill for the next days. So we will share with you this task and some links for setup gazebo simulation and presentation, of course, and be prepared to share with us your task. So you can write all questions in our Telegram group. So, and also you can share your result in the Telegram group.
Okay.
Yeah. Don't hesitate. It will be very great if you perform the first, share it, and it will be motivate for all participants to provide hurry up in the gazebo installation and perform the task. Okay, so guys, is it clear for you the homework task? It's okay?
Okay.
Okay.
Yes.
Okay, great. Okay, perfect. So next one on the most important information. So we have prepared the form of the daily feedback. It's a short form with simple questions, but your answers will help us to make the next day is better than today. Please fill this form. This link will be shared in Telegram group in 1 hour. And all materials we will share it in near time too. Before we go to this step, so guys, any questions about organization information for you? Maybe you want to add something? Silence. Okay, no problem. One more thing before we go to to take a common photo. So Ilya, are you here? My chief communication interpreter. Ilya?
Yes, Svetlana, I'm with you.
Yeah, great, perfect. So please.
Hello.
Yeah, hello. Okay, I will.
Do you hear me?
Yeah, we hear you. Yeah, we hear you. Ilya, hear you us? No. Ilya, we hear you, but we don't know why you don't hear us.
Svetlana?
Yeah.
It's really weird. Your voice was just muted for some time. Anyway, I'm with you.
Okay, perfect. So you have an idea to make some short introduction for all of our participants. So could you explain it, please?
Yeah, surely. So, hi everyone once again. I had an idea that to know each other better, I suggest every one of you prepares a short introduction consisting of 2 parts. First of all, I think it would be really interesting to get to know you all, so please prepare some short bio describing like where do you come from, how did you decide to do stuff with drones, how did you find us, and all things describing you and drones relationship. And as for the second part, we'd love to know more about drone education in your countries. So please prepare some, I don't know, short story about how drone education in your country works. Maybe there are plenty of drone pilot schools, or maybe drones are even widely used in some businesses like geodesy, cartography, and other stuff. Maybe you even work for such businesses, or maybe even like in Russia, the drones became an official occupation to study. We really love to know more about drones and drone education in your country and you. So guys, we do really hope that you prepare some wonderful speeches so that you can get to know each other. And because like the main idea of us gathering together is not only just learning some stuff, but also transforming into community of drone enthusiasts. And so, guys, I do hope I've motivated you enough. And we'd be expecting some presentations. You can even make it in the form of presentation or a short video. Everything will do. Just be creative. Looking forward to your presentations tomorrow. It can be, I think, 3 to 5 minutes. That should be enough. Svetlana?
Yeah, thank you, Ilya. So I'm afraid that they cannot have enough time for tomorrow. Maybe we will separate this presentation, okay? Or maybe we will we will provide it in several days, okay? So, but
just please prepare it tomorrow.
Okay. So we will share with you this information. It will be a good opportunity to provide some introduction for you. And for now, I suggest to turn on your cameras and take a common photo, guys. What do you think? Yeah, I see.
Who?
Nurlan, we don't see you. Yeah, Jorge, Nikita, we don't see you. Ismail Rodriguez is here. Sebastian is here. Danny, Lena is here. Danny, we don't see you. Oh, sorry. Okay, you will send us your selfie. Okay, guys. So where is your smile? Are you ready? I will make several photos. I'm going to take a screenshot. So the amazing photo starts in 3, 2, 1, smile. Great. Just a moment. Okay, so let's try again. And 3, 2, 1, smile. Okay. So guys, the last chance to take a common photo for all. Aura, Lewis, Stefania. Okay, so are you ready? The last chance. 3, 2, 1. Smile. Hey, great, great. Okay, and okay, thank you all. So, guys, what about your mood? So, you have tired or no? Maybe you have any questions, or it was very big information for you in the first day. What are you doing, guys?
Well, to be honest, I have one question.
Yeah.
So the sample codes that we are going to do in the homework are on the web page, right?
Yeah, the
Yes.
code is on the web page, and you can find it easily if you go to clover.coex.tech.
Timofey, could
All
could you share the link of this example?
Yes, I will send it in the Telegram.
Yeah, you can send into Telegram, and also we collect the message with materials and links, I think, and we will share with you in a near hour. It will be convenient for you.
All right, thank you.
Okay. Anybody else? Don't worry, guys. The homework is simple. And we will see you tomorrow. Okay, if you don't have any question, I would like to say many thanks to Timofey for his hard work, and many thanks for you for your hard work for today. And we expect many questions from your side in our Telegram group, and we will answer it on it. And Lena and Nikita will help you during all time during the camp. So I think we can finish. So guys, you can unmute your microphone and say goodbye, or in Russian will be пока-пока, до завтра. And say it in your native language.
Goodbye.
Goodbye. Thank you a lot.
Bye.
Goodbye. Take care.
Goodbye.
Bye-bye.
Thanks a lot.
Yay, bye-bye, bye-bye. See you tomorrow, guys. See you tomorrow.
See you tomorrow.
Bye.
Goodbye.
See you tomorrow.
See you
Buenas
tomorrow.
noches. Ciao.
Oh, ciao, ciao.
Ciao.
Пока-пока, пока-пока.
Пока. Is right? Пока-пока.
Yeah, in Russian. Пока-пока.
In Russian? Пока-пока. Okay.
Such as bye-bye.